Hello, everybody. It's now time to talk about MergeSort, or the recursive sorts. Now, recursion is essentially when a function calls itself over and over again until it completes whatever task it needs to do. The easiest uh, recursive function to look for is probably the factorial function in Python, right? So if we take a quick look, uh, the factorial function. There's actually a couple of different ways to do the factorial function. Hey, stop right now. Okay. So we can just make a simple for loop to do it, which is what you see here. Or maybe you don't see. I may have to, I forget my screen is not allowing me to use the magnifier here. But there you go. A simple for loop. What a factorial is if I say 4 factorial, it's the same as saying 4 times 3 times 2 times 1, like that. Uh, So if I were to say, 8 factorial, it's 8 times 7 times 6. We just go down by 1 each time. So we have a for loop that can do that. But you can also create a function that does it as well. Let me see if we can find it. I'll back up a little bit. Recursive. Recursion. There we go. So the recursive version of this looks like this. Now what ends up happening here, we saw kind of a for loop version. It's just essentially, we count down and we multiply. We have a little counter that uh, times equals and accumulates whatever the previous number was and then multiplies by the next each rotation. Uh, Recursion has an end case. This causes it to end once we hit 0. Uh, and this line here is what causes our recursion. This function is called factorial. And we're going to return, let's just say if I look for 3, we'll pick a small number here. It's going to return 3 times, but then there's this factorial 3 minus 1, which is 2. So essentially, it's got to run this before it can return. So it runs this again, factorial 2. 2 is not equal to 0. So it's going to come here and it's going to do 2 times, 2 minus 1 is 1. Then it's going to run through this. And it's going to say if n equals 0, well, it's not 0, 1. So this will end up basically returning 3 times 2 times 1 times 1. Actually, I wonder if I couldn't just set that to 1 and stop it there. I guess it doesn't particularly matter for what we're doing, but recursion is generally going to be considered significantly faster than, let's say, just setting up a loop. A lot more efficient. So you can kind of see what ends up being returned as we go through this list. 5 times 4 times 3 times 2 times 1, and then it finishes. It ends and comes back up. Yeah, actually, I think we could just say equals 1 and it would not have that extra 0 there, perhaps. But anyway, this still does what we want to do. That's what recursion is. So let's take a look at MergeSort. I will try to zoom in so you can see it. All right, so this is MergeSort. We've seen all these other sorts. Let's take a look at MergeSort a couple of times and see exactly how it works. So if you're paying attention, you may notice that it starts sorting a couple of different areas. 1, 2, merge. 1, 2, merge, merge. So there's 2 functions involved in this. There's kind of a split function that splits the array up, and then there's a merge, which, and the split up also goes in the merge, which also sorts, and then we merge them together. So let's break this up into steps. In this case, we're splitting this up into 4 separate arrays. We are sorting each of the 4, and then we have a function that merges those 2 together. If you remember, again, like shell sort, if it's already mostly sorted, then it goes faster. So the premise is, with this, we will sort the 2 arrays and merge them together because they're already mostly sorted. And then we'll back out and we'll have those, we'll have 4 arrays essentially, and we'll sort all of them or merge them together. So MergeSort is significantly faster than pretty much most of these others. The other one we're going to look at is QuickSort, and we'll do that in this video as well, so we can kind of compare the two. Let me try to get my screen back to working here. Okay. Ooh. Okay, there we go. So I've got MergeSort up here, and I've also got BubbleSort, which we don't really need. So I'll just close that out for now. All right, this is MergeSort. Now, just like my previous sorts, and I'll go ahead and keep shell sort up here for now, so we have a comparison from the last time, for example. We already know BubbleSort is terrible, but I tried to make these a little larger too, so you can see it. But I've got my timers and my fills, same as before. Our main area is pretty much the same as before, except this time it's going to have the MergeSort in the middle. And you'll see there's a little bit of stuff there. It's a little bit different. But let's look at the MergeSort itself. It's actually pretty sizable. Now I rearranged like some of the code for this. L and 1 look very similar, except for the little curve down. So it was confusing some people. So I've adjusted so if you see some things that are capital and some things that are lowercase, that's why I really should be more consistent. But I didn't want a whole bunch of lowercase l's plus 1 because that is just confusing to read. So I'm using uppercase L, and that had made me have to change a couple of other places that were using uppercases already. So, but this should be the working version. So let's talk. We have merge and we have MergeSort. Those are the two functions. Let's look at MergeSort first. It's smaller and it's the start position. So again, as usual, you can go ahead and pause and copy all this code down. I'll turn on the line numbers to help you out. We'll go back up to, I'll tell you what, before we go out to merge, I'll slow down so you can copy it down, pause as needed, and then we'll walk through the code. There, there, there. All right. Hopefully you paused, got everything written down, and hopefully it works at some point. All right, so I've got MergeSort. And what MergeSort's going to do is we're going to pass it an array, and we've got a left and a right, which if we look down here, you'll see that's basically the position in the array where that is. So we initially pass it the 0 and then whatever the length is minus 1. So if I have a 20 array, it goes 0 to 19, so that'll give me 0 to 19. So what it's doing is passing the entire array that first time. Then we check to make sure that 0 is less than, the end number. And then we split that in 2. And then we call MergeSort again on the left side that we split in 2. MergeSort again on the right side that we split in 2. So this is just going to recursively split the array and then split that and then split it again and then split it again. And it's going to keep splitting it until it can no longer split it. Now once it's split it, it's going to run merge. And we come up here, we've got quite a lot of math going on here. We're creating temporary arrays here of whatever the left and right side are. We come down here and we kind of populate those. That's what we're doing here. Copying the data over. Then we set some initial locations for like where we are in those arrays. And then we have, well, a lot of looping here. And again, I've tried to include the like end points so you can see where those all are, making it a little easier to write out. But we're basically doing some comparison, doing some swapping, sorting. Now we've got, of course, left and right sides. So we're trying to make it all the way through all those. We come down here, and I've got my little comment set up here so you can kind of see what's going on. Now, once it finishes sorting all that, it backs out, of course, and by this point, we should be kind of merged together. Let's take a quick look and make sure this sorts, just like all our previous examples. I'm going to set this to a 10, and I'm going to run it. And hopefully you can see that, but it looks fairly sorted. Okay, so we know that is doing its job. It's always a good idea to do that first, because it's very easy to, when you're especially copying down code, to leave out a plus or to put an L instead of a 1, or, like just mess something up, put a less than or greater than sign when you don't mean to, or forget to put a less than or greater than sign. Something that says it's supposed to say less than or equal to will totally mess this up and things will be out of order, and you've messed up one of your items here. So now it took no time at all for 10. So let's go through our usual run. 1,000. We run. Oh, shell sort's actually a little more efficient. We take a look. We run again. 10,000. Okay, 0.16. 100,000. This took, I think, shell sort, what was it, 5 seconds or something? Oh no, I think that was 1,000,000. Took 5 seconds. So we're going up again to 1,000,000. 2.5 seconds. So it's actually slightly faster than shell sort. And as we get larger, shell sort falls off because it's not a recursive sort. And of course, if we tried bubble sort, we'd be in for a world of pain. So we're not going to bother with bubble sort. Now let's close you for now. So that right there is MergeSort. Let's take a look at QuickSort too while we're here. There we go. Voila. Now, I'm going to show you QuickSort first. This would be QuickSort, and again, I'll try to zoom in a bit. All right, so there's actually a couple of different versions of QuickSort. They kind of do the same thing though, so I'll just use the basic quick. Now, the way QuickSort works is it finds what's called a pivot value. And around that pivot value, it moves all the smaller numbers above it and all the larger numbers below it. Now, if our pivot value that it finds is kind of not near the center, it tends to not be as efficient. But what we're doing is basically, again, splitting our array up. We're sorting one side and sorting the other. And of course, if you click on this, you can actually see the algorithm and everything for how this works. And there is another version of the QuickSort. You'll see it's a 3-way partition. It's a little bit different. We can click on each of these and see kind of how it runs. And there's not a huge difference. It just depends on the data set for the most part. So let's take a quick check. We got our MergeSort. We've already seen that. QuickSort. So QuickSort, again, set up the same way. We have our timer functions, our imports, our end, we have our fill. And then, of course, we have the actual functions. We have partition, which kind of splits our array up. We pass it the low value and the high value. It picks a pivot value, like I mentioned before. And then splits the arrays up and starts sorting them based on that. QuickSort is our entry, just like MergeSort was. We come in, and we have to find a pivot value, which is going to be basically the middle value for the most part. Uh, Usually, that's what our partition's doing up here. Once we find that pivot value, we split the array up and quicksort the first half and quicksort the bottom half. So again, we're doing kind of something similar to MergeSort. We're splitting this up. There's a theme in programming called divide and conquer. And if you can divide something up into smaller parts, usually you can finish it faster. A good example would be like if I wanted to paint a room by myself, it might take me an hour, right? If I get another person, maybe we can do it in 30 minutes. If I get 4 people in the room, or 3 people and me, that makes 4, then we might all be doing it in 15 minutes, right? There does come a point to where there's just too many people in the room and you're getting in each other's way, but yeah, the more heads you have, the faster things go. Now, like before, I'm going to test and make sure this is sorting. I'm going to pick just 10 numbers. I know the fill is working, so we've tested it in the other programs and it's the same one, so we'll run it. And that looks fairly sorted, I'd say. So we're working. So let's see. We'll try the same run, 1,000, which should be negligible to no time at all. Yep, okay. We'll do it 10,000. 0.75, okay. 100,000. 0.1 seconds. And 1,000,000. And then we wait a couple of seconds. There it is, 3.8. Okay. So that was MergeSort. Do I still have our option here? Okay, so we've got, let's see, this should be 1,000. So if we line them up, let's do it this way, I guess. Be the better way to go. Like that or something. Okay. So 3.8 seconds for MergeSort, 5 seconds for, I'm sorry, 5 seconds for MergeSort, 3.8 for Quick. 0.2 to 0.1 is actually twice, 2.5 times slower. We get to 0.018, 0.075, about 2 times actually here. And then we just can barely tell. On smaller data sets, sometimes the recursion is a little slower. So it's one of those cases where, although it is significantly more efficient, there are times where it isn't any better than some of the others. So this gives us quicksort. Now, of course, I could do 2 million and, I'm sorry, 10 million rather. And by the rate it's going up, I'd be waiting a little bit, not a tremendous amount of time. Certainly, it's not something I would try with any of the loop sorts, even shell sort. But hopefully you kind of get the gist of how that works. This is QuickSort and MergeSort, the last of the recursive sorts that we're going to go over. There is also heap sort. I don't generally go over it, but if you want to take a quick look at how that works. And the algorithm for it is actually somewhat more complicated than the others. So I don't have any actual code to show you, but yeah, if you're interested in that, you can look it up and probably find it fairly quickly. It's obviously a recursive sort. It takes little to no time really to do all these. If we compare it to everything, which we can make them go all at once, we'll probably see this side finishing first, depending on what's going on, and our loop sorts are still going to piddle along. Of course, I could make these bigger, but that would just, amplify the time even more. And as we see, we can see it merging a little clearer. Well, at least I hope you can. And all this side is finished while I'm still doodling around for most. Selection sort, bubble sort, barely finished, barely started rather in some of these. And you see QuickSort does have its worst case there. But that's the rough gist of sorting algorithms. Hopefully you enjoyed that. And hopefully now you know kind of the different ways we can kind of approach this problem. This is kind of applied to a bunch of different places. For example, a game. You ever go to an area in a game where all of a sudden the frames per second drop to like really low, and it's always in that one specific area? It could very well be some algorithm that's like not displaying correctly. And it's would become somewhat similar to what we're doing here. Maybe they just need to find a more efficient way to display things. I know there was a couple of games where they were rendering like everything, even stuff you couldn't see, and the drag on the game was just significant. So what they did was adjust it. So they still kind of loaded some of the stuff you didn't see in case you like dug down or got to it, but they didn't render it on the screen. There's you know a bunch of different ways to kind of get the same result, and of course that all depends again on your computer and your setup. So that is MergeSort and QuickSort. If you have any questions, as always, please let me know.